All right, so logs are basically rewrites. This is day 2 of logs, and so I'm going to go through this kind of fast. But if you have a problem like this is an exponential problem, and it can be written like this. Notice I had to go to the other side. I went 7, and then the 8, and then back to the x. These never go in order. So if I was going to rewrite this, I go 7 to the x equals 8. 7 to the x equals 8. You could keep rewriting in a loop like that forever if you wanted to. Log base, and obviously there'd be no point to that, but 7 of 8 equals x. This form is cool though because you can rewrite it as a base 10. Do you get how it's in base 7 right now? If you want to rewrite it as base 10, I showed you how easy that was before. All you have to do is go log 8 over log 7. You might be like, well, why is that in a different base? Because, think about it. Did I ever say what base these were right here? And if I didn't say what base they were, then what base are they? They are the most common base of all, which is what? Nope, base 10. So if maybe I didn't cover that point well the other day, I'm going to say this again. If I just say log 8, that means log base 10. If I didn't say what base it is, the default base is base 10. Which means like that. And then if I don't have any x in the problem, I can always set it equal to x, and then I can rewrite it. That rewriting thing is the most important thing about logs. So this would be 10 to the x equals 8. 10 to the x equals 8. So which form's easier to use? That form's easier because it can go into a calculator. That form can't go in the calculator. Now the only time it might be nicer is if this 8 was actually like a 100, because then do you get that I could say 10 to the what is 100 and I could do that in my head? So if you can do them in your head, then this form's better. If you can't do them in your head, then this form's better because it can go in a calculator as log 8 over log 10.
Would it matter if you still the same answer?
Okay, if you put it in the calculator, you get the same answer as if you do it in your head? Absolutely, yes. It's just that it's obviously faster. If you just look at this, can't you just say, oh, the answer's 2? That's faster than a calculator, right? Okay. But if you had gone, now again, this isn't the same. I should change this if I'm going to do this. This I changed to a 10, or I changed to 100 down here, so this will be like this problem. And if you type in log of 100 over log of 10, it will give you log. Actually, there'd be a faster way. Since this is in base 10, all you'd have to type is log 100. Because base 10 is the one that your calculator does automatically. Okay, so if I say log 4, what base is that in? Base 10. Can your calculator do it? Yeah, you just type in log 4. Because your calculator is doing base 10 automatically. So if you go ahead and do that, if you have a graphing calculator, get it out, type that in. Yes? What? That's not okay, though, because I have too many kids that will abuse that. So you can borrow one of mine if you want. Otherwise, use a graphing calculator. Actually, your iPad calculator could work too if you want. For these, they're not that hard. Okay, what is log 4? Some decimal, what is it? Give me the first 3, would you? Thank you. Okay, so if I want to know what that looks like, if I made a graph of log, it looks kind of like this. And log 4 means I've gone over 4. And I go up 0.62. It's just a really, if you kept graphing this would go on forever, slowly, slowly, slowly going up. And anyway, if you do log, if you wanted to go log base 3 of 5, that is a base 3. Your calculator can't do base 3. So you've got to change it so your calculator can handle it. Your calculator can only do base 10. So you change it to log 5 over log 3. You get what just happened there? It's almost as if I drew a line right there and said another log. Log 5 over log 3. And then when you do that, you're doing base 10. Because see how if there's no number here, there's a little 10 there, really. That's the only one your calculator can do. Actually, it can also do base E, but you're not going to learn about that till tomorrow. So for right now, we'll just do log base 10s. All right, so a typical question today looks like this. Log base 3 of 9. And do you remember how that kind worked? What do I change the 9 to? Come on. 3, nope. Log 3 squared is 9. So there. I've changed it to that. 3 squared. And why did I do that? If you make these two bases the same, then that's the answer. That's all there is to it. So I'll give you another one like that. Log base 5 of 25. Would you agree that 25 is the exact same thing as 5 squared? The reason you want to do that is you want the bases to be the same. Do you remember that statement? If the bases are the same, then you can get the answer easily. Do you remember that? All right. Some of you aren't with me. Be with me. Okay. If the bases are the same, then that's the answer. Okay. So if I want to make this a little more extreme, log base 3 of 81. What's the answer? Well, you could make 81 into 3 to the something. Did you know that? 3 to the third is 27. What do you think 3 to the fourth is? 81. Okay, so 3 to the fourth means 3, 3, 3, 3. 9 times 9. Get that? It's 81. Make sense? Okay, so why did I just rewrite this? So that the bases would be the same. The base of the log and the base of this little exponent right there. The bases are the same, then that's the answer. I can prove it to you in one more way. If I said log base 2 of 2, let's make it to the third to keep it simpler, because I don't want them all to be 2's. Then, do you get that there's no x in this problem? So I can say equals x, and then I can do a rewrite. How would I rewrite it? 2 to the power of, always jump, x equals, always jump back. What's that? 2 to the third. Do you get how I now have two bases? Do you get how their exponents have to be the same then, and therefore x has to be 3? But we don't make you show all of that work. Because it's so simple. If you just know the pattern that if these two are the same, then that's the answer. So one more like that. Log base 7 of 49. What's the answer? 2, because you could write 49 as 7 squared, and the answer is going to be 2. You could do it the long way if you want. Equals x. 7 to the x equals 49. And then you could figure out that x must be 2. Okay? All right, one more pattern you need to know. Let's say it goes like this. 5 log base 5 of 7. It's a pattern. 5 and 5 are the same. That's the answer, 7. I can show you why, but math's full of patterns like this, and this pattern will save you a ton of time. Because here's what you'd have to do if you wanted to prove it. You have to say equals x, because there's no x around, right? And then, do you get how this one is actually not a log problem? The log is up in the exponent of it. So this is actually written as an exponential type problem, or an exponent problem, where this is the base and that's the exponent. If it's then an exponent problem, you can write it as a log. So I go log, and what base does it have? Well, that's the base number, 5. And then you got to jump around over to there of x equals, and then you got to jump back, and that's the rest of it. Log base 5 of 7. Now look at that one. Do you see how there's log base 5s on both sides? Can you see that x has to equal 7? All right, now would it have been faster to just look at this problem and say, oh, since these are the same, that's the answer? Yes? The first thing. Nope, I don't know what you mean by the first thing. Okay, the first way to solve this, the first way was just to notice that these two are the same, and that's the answer. I was just trying to show you just now why that's true. But the reason why it's true is I set it equal to x, and then I rewrite it like this, and it shows you that x must be 7. But here's the key. You'll catch on, just watch a few of them. 9 log base 8 of 9. Does this one set up right or not? No, so this one doesn't work. You would not be able to get this answer without a calculator. But this one is set up right, so what's the answer? 12. Some of you are not with me. Be with me. Yes? How would I solve that if I had to? Are you going to do this? I don't think you, all right, so I'll do it for you again. Equals x. And now, why did I say equals x? Because there's no x in it. And now if I'm going to rewrite this puppy, this has a base of 9, so I'd say log base 9. And then I got to jump around. You always have to go back and forth to find your next number. I got to find the next number is x. And then I jump back here and get the rest of the answer. Log base 9 of 12. And now that they're written that way, you should be able to see that they both have a log 9, and therefore these two have to be equal. But that's just a proof of it, and you would not be forced to prove it. You would just need to know the pattern, that if these two are the same, that's the answer. Again, I like you to know that. I just don't want to kind of keep beating it to death, because you are going to eventually become really quick at these. This requires you to remember something. What did I say when you didn't give the base? What is the base then? So what's the answer to this question? 5, because there's really a 10 right there. And therefore, these are the same, and therefore the answer is that. Okay, here's back to the other kind. Log base 3 of 9. What's the answer? 2. What's the answer now? 3. Because really 27 is 3 to the third, and that means that that's the exponent. That's the answer, is 3. Could you set it up the long way? Equals x. 3 to the x equals 3 to the 3. 3 to the x equals 3 to the 3. Now, x must equal 3. That one's a lot quicker to do the long way. That other kind's pretty brutal. All right. So, last kind of question. I want to actually do your homework with you. Grab your worksheet if you haven't already got that up. Get your homework worksheet up now. And do you notice a lot of these have the same base already? Here, look. Those are the same. What's the answer? Negative 0.23. That's all there is to it. Okay, these are the same. That one's the same, and that's the same. So what's the answer? The exponent, 5, 6. But what if they're not the same? Like, for instance, in that one, you just rewrite the 8 as 2 to the third. And then the answer would be what? 3. How about this one? This is definitely tougher. Do you get how those bases are not the same? So I have to rewrite this 3 halves as 2 thirds, but it's not the same. So I got to put it to the power of what makes it flip? Negative 1. And then that is a power to a power. You get how the inside there is a 2 thirds right in here is supposed to be a 2 thirds, and then I'd have to put it to the negative 1. And if it's to the negative 1 power, those 2 powers multiplied together are your final answer. Man, that's really messy. It's hard to do. I'm going to do just a rewrite. Log base 2 thirds of 2 thirds to the negative 1. That's what gets it to flip over and be that. And then I still need to the power of negative 0.23. So now that these two are the same, that and that are the same, the answer is those guys multiplied. All right. By the way, what's 7 to the 0 power? Do you remember me saying about if you won the argument, log base 8 of 1? If there is a 1 in the argument spot, if you've won the argument, you get what? Nothing. So the answer is 0. Anytime there's a 1 right there in this spot, then the answer has to be 0. What about O? What are you talking about? That's a 0. Oh, you mean letter O on the worksheet? Okay. All right. On this one, so that's 9 to the 1/9 power. Do you get the root 9 means? Root 9 means the roots are on the bottom, remember? That means that. Okay. All right. Now we're going to move to the end of the worksheet. Everybody slide down, and even if you were in the middle of working on a problem, stop and get to this bottom section, please. Okay, this one. Get how it doesn't have an x? I'm going to say equals x. And that'll help me do this one. 4 to the x equals 5. What they want to know is, what's the answer between? Would you agree that 4 to the first would be too small? 4 to the second would be too big. So it's between the first and the second. So you go between 1 and 2. X must be between 1 and 2. All right, now I'm supposed to express it as base 10. That's that thing I was talking about before. How do you rewrite log base 4 of 5? You write it as log 5 over log 4. Log 5 over log 4. Then when it says value, oh, wait a minute. On this one, some people might be like, but what do you mean? Where's the base? There isn't any base, which means, what is the base? 10. So it's really log base 10 of 5 over log base 10 of 4. But we don't have to write that. If we write log 5, it means log base 10 of 5. All right. And then that last thing, you'd actually type this into the calculator, and it'd give you a decimal like 1.16 or something like that. You'd type in log 5, divide by log 4, enter. Yes, ma'am. It's a good question. It depends. If you follow the nomenclature of your calculator, basically, if your calculator's got an empty parenthesis at the end and it looks like it needs to be completed, then you should do the end parentheses. Depends on what kind of calculator you're using. Because on the iPads, it might be one way, and something else might be something else. But how about this? If your answer doesn't come out between 1 and 2, you probably did something wrong. If it comes out between 1 and 2, you probably did it right. Okay, so it's as simple as type in log 5 divided by log 4. All right, that's how you do today's homework. I know it's a little bit of a strange lesson today, but I didn't have access to my normal smartboard for my other classes, so I thought I would give you the same experience so that they don't get ahead or behind you. And it is about lunchtime. That's all I have for the video for today.